You burned a letter once. Maybe you remember it. The paper caught at the corner first. The edge turned brown, then black, then curled inward like something alive trying to escape. The words disappeared. The ink, the sentences, the thing you wrote and chose not to send, gone. Or so you believed. Here is what physics has quietly known for decades, and what most people will go their entire lives without confronting. That letter was never destroyed. Not one atom of it. Not one quantum of the energy that held those words together. Not one piece of information encoded in the arrangement of ink on paper. The universe does not have a delete key. It never has. Everything that has ever happened, every fire that has ever burned, every star that has ever died, every thought that has ever passed through a human mind is permanently, indestructibly written into the fabric of reality itself. This is not poetry. This is not philosophy reaching beyond its boundaries. This is one of the most rigorously defended principles in all of theoretical physics. And its implications are so vast, so strange, so quietly devastating that most physicists prefer not to think about them for too long. Tonight, we think about them. Tonight, we open the ledger. Act 1. The receipt you didn't know existed. The burning book. Let's begin with something simple. A book. Say it's a novel, one that exists in only a single handwritten copy. No digital backup, no second printing. The only one of its kind in the world. You burn it. The common understanding is straightforward. The story is gone. The characters, the sentences, the particular arrangement of ideas that made it unique, erased from existence. The universe has forgotten it. But watch what actually happens when you burn that book. The paper, cellulose, a long chain of carbon, hydrogen, and oxygen, breaks apart. The carbon atoms bond with oxygen in the air and rise as carbon dioxide. The hydrogen becomes water vapor. The minerals in the ink disperse as fine particles of ash, carried by the thermal updraft, spreading across the room, the building, eventually the atmosphere. Nothing was destroyed. Every atom that was in that book is still in the universe, rearranged, dispersed, scattered across an enormous and growing volume of space, but present. Now here is where it gets strange. According to the laws of quantum mechanics, specifically the principle physicists call unitarity, it isn't just the atoms that survive. The information survives. The precise quantum state of every particle in that book, the exact configuration that made it that book and not any other arrangement of matter in the universe, is encoded, scrambled but intact, in the quantum states of every smoke particle, every photon of light released by the flame, every vibration in the air disturbed by the heat. If you could track every single particle, every photon, every carbon molecule, every quantum of energy released by that fire, and if you could run the equations backward, you could reconstruct the book, word for word, page for page. This is what physicists call the no-hiding theorem. Information cannot hide, it cannot be erased, it can only be moved, scrambled, redistributed, but never, under any circumstances permitted by the laws of physics, truly destroyed. The universe keeps a receipt for everything. Why this had to be true. To understand why physicists insist on this so forcefully, you have to understand what would happen if it weren't true. The laws of physics, the equations that govern how particles move, how fields evolve, how quantum states change over time, are reversible. Run them forward, you get the future from the past. Run them backward, you get the past from the future. This is what unitarity means in quantum mechanics. The mathematical operation that evolves a quantum system through time is perfectly invertible. Given the final state of a system, you can, in principle, always recover the initial state. This is not a convenience. This is not an approximation. It is a hard structural feature of the equations themselves. If information could be destroyed, truly, permanently lost, then that reversibility would break. The equations would become one-way streets. The future could be calculated from the past, but the past could not be recovered from the future. And that would tear a hole in the mathematical fabric of physics so fundamental that almost nothing we know about how the universe works would remain standing. Quantum mechanics would fail. Thermodynamics would fail. The entire theoretical architecture built over 3 centuries of careful observation would quietly collapse. So physicists defend the conservation of information not merely because they believe it. They defend it because the alternative is a universe that simply does not compute. The most dangerous question. But here is where a shadow falls across this beautiful, orderly picture, because there exists one object in the known universe that appears on the surface to violate everything we just described. You already know its name. A black hole. When matter falls into a black hole, it crosses the event horizon, the point of no return, beyond which nothing, not even light, can escape. And when a black hole eventually evaporates, as Stephen Hawking showed it must, slowly radiating energy in the form of what we now call Hawking radiation, the question becomes unavoidable. Where did the information go? Hawking radiation, as Hawking originally calculated it, is perfectly random. It carries no imprint of what fell in. A black hole that swallowed an encyclopedia and a black hole that swallowed an equal mass of featureless hydrogen gas would, according to Hawking's original calculation, produce identical radiation as they evaporated. The information, he concluded, was gone, destroyed. This became known as the black hole information paradox, and for nearly 50 years it has been the single most ferocious battleground in theoretical physics, because it forced 2 of the greatest frameworks in science, quantum mechanics and general relativity, into direct, unresolvable conflict. Quantum mechanics says information is eternal. General relativity, as applied to black holes, seemed to say it wasn't. Both could not be right. And yet, in trying to resolve this conflict, in the decades of argument and calculation and brilliance poured into this single question, physicists stumbled onto something that reframed not just black holes, but the nature of reality itself. But that discovery, we'll reach it soon. First, we need to understand what the universe is actually made of. Not matter, not energy.
Act 2. The universe is made of information. In 1989, the physicist John Archibald Wheeler, one of the architects of 20th century physics, the man who gave black holes their name, stood before a conference and said something that should have sounded absurd. He said the universe is not made of matter, not made of energy, not made of fields, forces, or particles. It is made of information. He called it from bit. Every particle, every field, every physical thing that exists, every it, derives its existence from answers to yes or no questions, from binary choices, from bits of information. Reality, Wheeler was proposing, is not a collection of things. It is a collection of facts, a set of answers to questions the universe is constantly, inescapably asking of itself. This sounds like philosophy wearing a lab coat, but Wheeler was pointing at something the mathematics of quantum mechanics had been quietly insisting on for decades. In quantum mechanics, a particle doesn't have a definite position until it is measured, until the universe, in some sense, is asked where the particle is. Before measurement, the particle exists as a superposition of possibilities. It is not here or there, it is both, weighted by probability. After measurement, one answer, one bit of information, one fact added permanently to the ledger. The particle didn't become real when it was created, it became real when information about it was recorded. If Wheeler is right, and a growing number of physicists believe the evidence is pointing in his direction, then the universe is not a collection of objects moving through space. It is a computation, a self-writing record, a ledger that has never, in 13.8 billion years, dropped a single entry. In the 1990s, the physicist Jacob Bekenstein was studying the thermodynamics of black holes, specifically their entropy, which is the measure of how much information is needed to fully describe a system. What he found stopped him cold. A black hole's entropy, its information content, was not proportional to its volume. It was proportional to its surface area. Think about what that means. A library stores books in proportion to its interior volume. Double the building, double the books. But Bekenstein found that a black hole stores information in proportion to its surface, its two-dimensional outer boundary, regardless of how much volume it contains inside. Gerard Tufte and Leonard Susskind took this result and pushed it somewhere extraordinary. They proposed that the entire three-dimensional universe we experience may be, in a precise mathematical sense, a holographic projection of information encoded on a two-dimensional boundary surface. Not a metaphor, not a thought experiment, a literal mathematical equivalence supported by decades of subsequent calculation between a description of physics in 3 dimensions and a description of physics on the two-dimensional surface that bounds that space. This is the holographic principle, and if it is true, the universe has a backup. Not stored in the objects themselves, not distributed through the matter and energy we can see, stored on the cosmic boundary, a complete two-dimensional record of every event that has ever occurred within the universe's entire history. Every fire, every collapse, every star that has ever burned, and every thought that was ever thought, written there, preserved, permanent. Return now to the black hole. Return to the information paradox, the wound Hawking opened. In 2019, 2 independent research teams, one led by Ahmed Almeri at the Institute for Advanced Study, another by Jeff Pennington at UC Santa Cruz, published calculations that represent the closest thing to a resolution the field has ever produced. Using a framework called the island formula, which incorporates quantum corrections to the geometry of spacetime near an evaporating black hole, they showed that the information swallowed by a black hole is not lost. It is encoded in the subtle quantum correlations of the Hawking radiation itself. Not obviously, not cleanly, not in any way you could practically read, but it is there. Scrambled across the radiation the way the words of a burned book are scrambled across smoke and ash, but there, intact, recoverable in principle. The universe, it appears, makes no exceptions, not for fire, not for supernovae, not for the most gravitationally extreme objects in existence. The ledger stays complete.
Act 3. The Ghost of Everything. 5 billion years before our solar system formed, before the sun ignited, before Earth existed, before the first ocean,
A star died somewhere in what would eventually become our region of the galaxy. It had burned for millions of years, fusing hydrogen into helium, helium into carbon, pressing inward against its own gravity until the pressure became fusion and the fusion became light. And then one day, its core collapsed. The outer layers exploded outward in a supernova. For a few weeks, that single dying star outshone every other star in its galaxy combined. Then it faded. The explosion dispersed, the remnant cooled. The star that had burned for millions of years became invisible within a few human lifetimes. But here is what the conservation of information tells us. That star is not gone. Every quantum of energy it released in its final explosion is still traveling, still moving through space, still carrying in its quantum state the precise imprint of the conditions that produced it. The shock wave of that supernova is still expanding. After 5 billion years, it has crossed an enormous volume of space, but it is still there. And the atoms forged in that star's core, the carbon, the oxygen, the iron, were scattered into the cloud that collapsed to form our solar system. Some of those atoms are in you, right now. The iron in your blood was forged in the nuclear furnace of a star that died before Earth existed. The carbon in every cell of your body was assembled in a stellar core you will never see. You are not separate from that dead star. You are one of its entries in the ledger, a continuation of its information, reorganized, made briefly and improbably conscious. Now bring this closer, much closer. You have a thought right now, perhaps about what you're hearing, perhaps about someone you love, perhaps about something you've been avoiding. That thought is a physical process, neurons firing in sequence, electrochemical signals cascading across synaptic connections, a precise pattern of activity in approximately 86 billion cells, each connected to thousands of others, a configuration unique to this moment, this thought, this version of you thinking it. And according to everything we have established, that pattern is a physical event, subject to the same laws as the burning book, subject to the same principle as the dying star. The quantum states of every particle involved in that thought are being encoded in the physical world around you, in the photons your warm body emits, in the sound waves your nervous system generates, in the infinitesimal gravitational perturbations caused by the mass of your brain rearranging itself as the thought forms. The information is leaving your mind as it occurs, being written into the fabric of physical reality, irreversibly. The version of you that sat down to watch this video, the precise configuration of matter and information that constitutes you at this moment, is, in a technical and literal sense, permanent, not in memory, not in legacy, not only in the impact you leave on others, in the actual physical record of the universe itself, encoded in quantum states, dispersed but not destroyed, filed. The cosmos does not forget its witnesses. We have to be honest about what this means and what it does not, because there is a version of this idea that wants to become something it cannot quite be. The conservation of information does not mean the people we have lost are somewhere intact, waiting. It does not mean consciousness survives death in any form we would recognize. It does not mean the subjective experience of being alive, the interior quality of a thought or a feeling, is preserved anywhere. The information that constituted a person is preserved. The quantum states that composed their physical existence are encoded in the ongoing state of the universe. But information is not experience. A perfect recording of a symphony is not the same as hearing it for the first time. And yet, the distinction between nothing remains and the information remains encoded permanently in the structure of reality, that distinction is not trivial. It is the difference between a universe that is indifferent to its contents and a universe that is, at a structural level, incapable of indifference. A universe that cannot look away. A universe that records everything that happens within it, not because it chooses to, but because the laws that make it function demand it. Whether that constitutes meaning, whether meaning is even a category that applies at the level of physics, is a question this video cannot answer, but it is the right question to be sitting with.
Act 4. The Ledger at the End of Time. The universe is approximately 13.8 billion years old. It will exist, by current cosmological estimates, for an almost incomprehensibly longer time. The last stars will burn out in roughly 100 trillion years. The black holes that remain after all the stars are gone will evaporate via Hawking radiation across timescales ranging from 10 to the power of 67 to 10 to the power of 100 years. After that, a cold, dark, nearly featureless expanse, maximum entropy, thermodynamic equilibrium, the heat death. But the ledger will still be there. The information that constitutes the entire history of the universe, 13.8 billion years of stars, galaxies, collisions, fires, and thoughts, will still exist, encoded in the quantum states of whatever remains, scrambled beyond any practical recovery, but present. The universe in its final state will be, in the precise language of physics, a perfect but unreadable record of everything that ever happened within it. Think about the scale of that record. Every photon emitted by every star that ever ignited, every gravitational wave from every black hole merger that ever occurred, every chemical reaction in every ocean on every planet that was ever warm enough to hold liquid water, every electrochemical cascade in every nervous system that ever briefly organized matter into something that could look up at the sky and wonder. All of it, every entry, preserved. There is a question that sits at the very edge of what physics can address and what philosophy must take over. If the universe is fundamentally a structure of information, if reality is, at its deepest level, a self-writing ledger, then what are we? We are arrangements of that information that have become complex enough to read other parts of it. We are the universe's own information looking at itself. When you observe a star, when photons that traveled for hundreds of light years enter your eye and trigger a cascade of signals in your visual cortex and produce the experience of seeing light, you are not separate from the system. You are the system becoming aware of its own entry. The star's information, preserved across centuries of travel, arriving at a piece of the universe complex enough to receive it, process it, and understand what it is. Physicist Carlo Rovelli has written that perhaps the universe is, at its core, a web of relationships, not things, but interactions, not objects, but the information exchanged between them. In that framing, we are not observers standing outside a universe of things. We are nodes in the web. Temporary concentrations of information processing complexity, briefly able to read and contribute to the ledger that contains us. The letter you burned was never lost. The star that died before Earth existed left its record in your blood. The thought you had a moment ago is, right now, being written into the physical structure of the universe around you. And this ledger, this vast, indestructible, perpetually growing record, has been building since the first moment of existence. It has survived every fire, every collapse, every death. It will outlast every star. It will outlast time itself, if time, as we understand it, has an end.
Conclusion. We began with a letter burning. We followed the smoke into quantum mechanics. We followed the ash into the nature of information itself. We followed the light into black holes and holographic boundaries and the question of whether the universe keeps records. Here is what we found. The universe does not delete. It cannot. The laws that make it function are written in a language that has no word for erasure. Information is conserved, always, without exception, in fire, in supernovae, in the slow evaporation of black holes across timescales that dwarf the current age of everything. The holographic principle suggests this information has a home, a two-dimensional boundary that contains, in principle, a complete record of every event that has ever occurred within the universe's history. The ultimate archive. What we cannot tell you, what physics cannot yet tell us, is what this means. Whether the preservation of information implies anything about consciousness or continuity or the things we reach for when we use words like memory or soul. Whether the universe's structural inability to forget us constitutes anything resembling care. These questions live at the boundary between physics and philosophy, and they are not resolved. They may never be, but they are the right questions. And the fact that the universe's own laws force them upon us, that is not nothing. The cosmos is not a void. It is a record. And you, right now, in this moment, are writing in it. The universe has no delete key. It never did.